Thanks to neuroimaging techniques, we have learned more about the brain in the last 15 years than in the whole history of humankind. The advances already made allow us to think that in the near future, we will be able to solve neurological damage, diseases like Parkinson's or Alzheimer's, depression or schizophrenia.
Yeah, I think that the revolution we're experiencing now is first the birth and the success of human neuroscience. We now have fields like cognitive neuroscience, where we use functional brain imaging and non-invasive brain stimulation to study the functioning human brain. And that was, I think, the first step. From my perspective, I've been doing neuroscience research for 30 years, and this is the revolution now. But now is the time that neuroscience is starting to reach into people's lives directly. And to me, that's what we need to have a revolution. We need to advance from the lab into the real world.
This is a software application to be able to control the Puzzlebox Orbit. I'll first connect it to the Emotiv Insight EEG headset. And that's now connected. What we have to do is train two patterns. The first is a resting state, so that we understand when you want to control the orbit versus not. And then the second pattern is to control what you want to apply for flying the orbit.
This leap from the lab to the real world can already be seen in the form of the perfecting of what belonged to the realm of science fiction just a few years ago: brain-computer association. The so-called brain-machine interfaces have solidified this revolution in the world of the neuroscience.
Well, BCI really just means brain-computer interface. So anything that makes a connection between processing going on inside your brain and a machine, some other device.
Brain-computer interfaces can be grouped as a group of technologies that can help both from a hardware and software perspective, able to both decode, process, and activate the interactions between humans and machines, decoding the brain, of course. Typical definition would be a platform that can help us interact from the brain to the world.
The brain-machine interfaces are bringing great advances in various therapeutical applications. Up to now, one of the main practical applications is the treatment of different pathologies associated with paralysis. At the Federal Polytechnic School of Lausanne, Switzerland, Dr. Jose Milan has been working for years on an ambitious project based on the development of a brain-machine interface that allows paralytics to control a robotic exoskeleton with their minds, thanks to which they can walk again or move a hand. The patients wear an electrode helmet that detects their cerebral electrical activity.
What we ask people to do at the very beginning, because they need to go through a training in order to acquire the capability to modulate voluntarily their brain signals, is to imagine the movements that they want to accomplish. And this requires some time, because it is not easy to do that. Our algorithms are capable to discover which are the areas, the specific areas that they are activating and desactivating, at which frequencies this is happening. And this is the input to our machine learning algorithms that will build the model of the decoder that will differentiate a opening, a closing of the hand, a right step, a left step, and so on and so forth. So during this training, people at the very beginning need to imagine the movement of their own body. And in many cases, people, after some training, and because the fact that as they imagine a movement of their body, this is executed via the exoskeleton, they don't need to think any longer about their own body. They think in terms of the exoskeleton, because the exoskeleton has been integrated somehow in people's body schema that we have in our brain.
The possibilities that this technique offers to these patients have allowed to a quadriplegic patient to be able to drive a Formula One car just with his mind. In 2017, Rodrigo Hubner Mendez became the first person to reach such a milestone.
This opportunity to work with Rodrigo was incredible. Globo TV in Brazil created a vehicle, a Formula One vehicle, that was completely controlled just using the power of thought. So what they used was our 14-channel Epoch Plus headset, measuring electrical fluctuations from Rodrigo's brain. He spent a few months mapping and training the algorithms to understand how he associated specific thoughts, whether it be drive forward, right, turn right, left, or stop. And then he was able to use those commands to drive this car completely just using his mind. So no steering wheel, no pedals, just him inside the vehicle. This was a very fortuitous moment when Lewis Hamilton, who is obviously the world's reigning F1 champion, was in the same place as Rodrigo in the UAE. Rodrigo posed a very exciting challenge for Lewis, which is, would you like to race me? Surprisingly, Lewis accepted the challenge, so I'm not sure when we're going to start seeing the two of them start practicing, but I know that Rodrigo is very excited about the ability and the opportunity to race with the reigning world champion just using his mind.
Around the world, a wide variety of projects based on brain-machine interfaces are currently being developed. In Boston, the company Neuroelectrics has developed a technology based on the use of mind-controlled video games to learn to regulate brain activity.
Okay, so today we are going to measure your brain waves with this device. This device basically uses dry electrodes to measure your brain waves like this. And today we are going to measure specifically your alpha brain waves. And you're going to be able to control an object in this screen going up and down. So I'm gonna put you the cap. Then we are first going to measure your baseline, which is the baseline of your brain waves, the level in which your brain is right now.
So the way we have developed our brain-computer interface is we are collecting brain signals, for example, alpha or beta or gamma, which are different frequencies, right? And we are coupling your brain or power spectrum, your brain bands, to something in the screen, which is in this case a little avatar that goes up and down according to if your brain waves are up or down.
So this submarine here, this is going up and down according to your brain waves, and you are controlling it. So you need to focus on it and keep relaxed and try to control it, moving it up and down.
The mind-controlled video games are proving to be an efficient treatment for diseases like depression or hyperactivity disorder in children. At Neuroscape, a neurotechnological company based in San Francisco, they are using these video games controlled by the mind for therapeutic uses.
All of our research right now relies on using the closed-loop video games that we've created, so far just using the performance, not the cognitive brain-computer interface. That's still very much in the research phase. And then we apply these closed-loop video game treatments to see if they can improve attention abilities in many different clinical populations, including ADHD, which is attention deficit hyperactivity disorder, but also post-traumatic stress disorder, traumatic brain injury, depression, and autism. We developed these closed-loop video games that record your performance and use that data to challenge you in a very personalized manner. So if it's too hard, the game could back off. If it's too easy, it can make it more challenging. It just puts it right at that sweet spot. And then the game mechanics target different neural networks that we're trying to improve. So it could be a prescribable treatment, just like we currently use stimulants to help improve attention abilities in children that are suffering ADHD.
In the last few years, there has been a progressive blossoming of neurotech startups that are revolutionizing the way to intervene in our mental processes. Nowadays, most of them are focused on helping patients with different types of damage or neurological disorders. However, in the not-so-distant future, these companies will end up transferring all these advances to our daily lives, radically modifying the way we interact with each other and even understand the world.
Investing in novel neurotechnology today could be the best way to generate an economic revolution in the future by the development of this new technology, which instead of biotechnology, in the case of the Human Genome Project, now it would be neurotechnology. And this is something that's starting to happen. Last year, Elon Musk created a neurotechnology company, Neuralink. Brian Johnson, another billionaire, has created a similar company called Kernel. So we're starting to have some new companies that are based on the promise that these new neurotechnologies are going to cause an economic revolution.
Emotiv is a neuroinformatics company. So what we do is we're a platform that allows us to interface directly with the brain. Today it's using non-invasive methods. So we start from the sensor input, so measuring the brain activity itself, through to the translation of the electrical signals from the brain, and then we map those to control and influence the environment around us. Look at your brain, Kim. So you're wearing a 14-channel EEG, and this is just picking up electrical fluctuations that result from neurons firing inside your brain. The brain is made up of billions of neurons, and when they interact, the chemical reaction just emits an electrical impulse that we can pick up. You can see that different parts of your brain is lighting up depending on what you might be thinking or whether you're paying attention to what I'm saying. So what we're doing here is we're mapping those electrical fluctuations into a 3D model of what your brain is doing, and each of the colors represent a different frequency band, which indicates how fast the information is traveling from one part of the brain to another.
Located in Lausanne, Switzerland, in the center of Europe, is the headquarters of MindMaze, one of the largest neurotechnological companies in the world.
And our big goals are really to disrupt industries from healthcare, so really improving quality of life after a neurological injury, all the way to being able to help healthy individuals, enable the ability of their brain to learn, to play, and interact, entertain.
One of those technologies designed to help the rehabilitation of patients who have suffered stroke is MindMotion Pro.
It's the first device a stroke or a brain injury patient sees after the injury. The first 2 days when they come out and they need to recover. It's one of the first devices that's able to start training of both the brain and the body. So it's about neuroplasticity, tricking the brain.
So we're going to put markers on you so that the camera can see your arms while we do some activity. So it's pretty intuitive. You'll just need to move your hand to the start button. And similarly, if you move it in the direction that isn't indicated, you'll see how to correct it.
So let's say someone who has a stroke cannot move the left hand, and he can move the right hand. The camera in the MindMotion Pro tracks the right hand and puts it on an avatar on the left side. And then the brain suddenly says, oh, something's happening there, so I should try more. And it starts activating the pathways that used to control that hand, and slowly it accelerates recovery.
The latest and most ambitious proposal of Mindbase, the CogniChip, goes one step further and merges neurotechnology with artificial intelligence. Some entrepreneurs are looking into augmenting our brains so that we can develop superintelligence that allows us to collaborate with artificial intelligence. It would be a way to reduce the risk for human beings to become irrelevant due to the rise of artificial intelligence.
It is the next frontier. Neuroscience and neurotechnology, brain technology is definitely the next frontier. Now we truly are at the frontier where we can do some impactful things with the brain. So yeah, neurotechnology is now really going to kick off.